So before we start discuss question 21A cancelled because that one no more in our syllabus for free falling bodies. So we move on straight to 21B. So we are given a velocity time graph for a toy train moving on a straight curve in 55 seconds. So question 1, we want to determine the time and acceleration at point P when the velocity is 0. So at this point where the velocity is 0, we want to determine what is the acceleration at point P and also the time. Berapa masa dekat point P. Alright, so since we are given VT graph, so kita faham apa konsep kita boleh apply dalam VT graph. So for VT graph, our acceleration actually is equivalent to gradient, sama dengan gradient, and then the distance or the displacement can be calculated from area under the graph. So for question 1, so in order to determine the time and acceleration at point P, you can consider this straight line lah. Okay, we can consider this straight line. So for this straight line, this is our initial point. So the initial point is 22, 12. Okay, this point will be 40, negative 8. So we can calculate the gradient. So that gradient will represent the acceleration at point P lah. So write down the concept. So the acceleration at point P equal to gradient. So we calculate the gradient. So we have negative 8 minus 12 untuk pasti y-axis. For the x-axis, we have final 40 minus initial 22. So you might pause the video to do the calculation. So the AP, if you calculate correctly, will be around negative 1.11 meter second negative 2. Okay, unit jangan lupa. And then we want to find the time. What is the time at point P? So berapa masa dekat point P? So we understood this is a straight line. So the value of acceleration at any point on this straight line is the same. So now in order to find for the time, we can consider here lah. Kita boleh consider yang ni pula. Kita consider bahagian ni. So point P2 become our final point. So time dia T unknown, then the value for y-axis waktu tu adalah kosong. Okay, so we do our calculations. So acceleration point P also equal to this one lah. So we have 0 minus 12 over T minus 22. So this value will equal to the value we just already calculate just now, negative 1.11. Okay, 0 minus 12 over T minus 22. So when we do the calculation, we will get the time will be around 32.8 seconds. Okay, 8 seconds. Okay, then we done question 1, then question 2. Question 2 is the total distance traveled by the train less than, equal or greater than its displacement. Justify your answer using calculations. So by doing calculation, we have to compare whether our total distance is greater than, equal or less than the total distance. So we have to calculate the distance, the total distance and also the displacement. So I represent distance using D. So distance is the area under the graph, whereby we are going to calculate the area dekat atas ni dengan area trapezium dekat bawah ni. Kita campurkan terus sebab distance adalah scalar quantity. So we have half. So tapak dia 32.8 plus width. Okay, 22 minus 10. 22 minus 10 adalah 12. Darab dengan tinggi dia adalah 12. Okay, campur dengan area of the trapezium dekat bawah ni. So we have half. So 55 minus 32.8. So we have 22.2 plus width, this one 43 minus 40 is 3. Okay, multiplied with the height of the trapezium is 8. Jangan masukkan negatif. Negatif tu adalah directions. So untuk kira distance tak perlu masukkan negatif. Recall balik apa kita discuss dalam tutorial. So bila kita buat calculations, we will get the total distance travel is 369.6 meter. Then we do the calculation for displacement. Displacement will be the area under the graph, but then we have to consider the direction. So we have half, samalah, kira dulu trapezium di sebelah atas, plus with half, trapezium sebelah bawah. Tetapi this time untuk kira displacement, kita kena consider direction. So kita kena masukkan negatif 8. Negatif 8. Okay. So kita dapat displacement kita 168 meter. So if you compare the distance and displacement, you will find out that your distance is greater than displacement. Okay, your distance is greater than displacement. Kalau you tak nak tulis macam ni, you might write distance is greater than displacement. Okay, then we done question 2. Then class, we have question C. A javelin is thrown with a speed of 55 meter per second at an angle 42 degree with the horizontal. So we sketch the situations. So at an angle 42 degree from the horizontal, we launch a javelin. At the initial speed of 55 meter per second. So since we launch it at an angle, so we understood it will perform projectile motion. Okay, it will do projectile motion. So we want to find the velocity of the javelin after time 5 seconds. Okay, so after time 5 seconds, let's say the javelin is here. After time 5 seconds, so we want to find for the velocity, the final velocity at time 5 seconds. So we understood for projectile motion, the velocity must be composed of component X and also component Y. Okay, dia mesti terdiri daripada dua komponen. So in order to find for the velocity, so we need to find for the horizontal final velocity and the vertical final velocity. So we track out the information first. Gunakan strategi dalam selesaikan projectile motion. So kita letakkan information kita dalam horizontal component dan juga vertical component. So we understood horizontally acceleration kosong, vertically the acceleration is equal to negative 9.81. Okay, so the initial velocity can be resolved into two components, horizontal component Ux and also vertical component Uy. So the horizontal component Ux will be 56 cos 42. The vertical component of the initial velocity will be 56 pula. Aish. 55 55. 55 sin 42. Okay, and then we want to find for the final velocity and also horizontal and vertical. So the final velocity for horizontal is always equal to the initial component sebab Ax kita kosong. So we have 55 cos 42. For velocity component Y, dia adalah varies with time sebab kita ada acceleration due to gravity. So kita perlu cari. So kita nak cari velocity ni at time 5 second. So our time is 5 second. So I already know the A, U, V, T. So saya nak cari V, saya boleh guna kinematic equations. V is U plus AT. But now I do it for component Y. Okay, so kita cari velocity component Y. So Uy is 55 sine 42 plus AY is negative 9.81. So the time is 5 seconds sebab kita nak cari velocity component Y at 5 seconds. So the Vy will be around negative 12.25 meter per second. Okay, so once we already obtain the Vx and also the Vy, then we can combine it using the theorem Pythagoras to find for the resultant velocity at time 5 seconds. So square root of the horizontal component squared plus with the vertical component squared. So we have 55 cos 42. Kalau ditekan calculator, component X ni is around, the value is around 40.87. So we have 40.87 squared plus negative 12.25 squared. Okay, so you might pause the video to do the calculations. If you calculate correctly, you should get 42.7 meter second minus 1. Okay, then we have to find for the directions because velocity is a vector quantity. So the direction will be shift tangent component Y divided by component X. So we have shift tangent negative 12.25 divided by 40.87. So we will get our angle is negative 16.8 degree. Okay, so then we solve the question.